AI never sleeps, and this week has been absolutely insane. We have a new open source video generator that's 5 times faster than the current leader, but just as good. This AI is pretty wacky. It simulates an operating system, but it's not actually an operating system. Like, nothing is predefined or hard-coded. It just generates everything on the fly and responds to your mouse and keyboard in real time. We have a new number 1 non-thinking model, and best of all, this is completely open source. It even beats the top proprietary models out there like Claude Opus 4. This AI can generate 3D models that are actually physically correct, like it gives you the correct size and scale and material properties. We have a completely open source robotic arm, which you can print out and assemble by yourself for only $500. This humanoid robot can autonomously swap its own battery, meaning it can continue to be powered and operate continuously without any human intervention. OpenAI introduces their latest feature, ChatGPT Agent, and a lot more, so let's jump right in. First up, we have a new open source video generator called Pusa. Yes, the name is Pusa. First it was Wanks, now it's Pusa. You gotta love these names that AI researchers come up with. Anyways, this is kind of based on Alibaba's Wan 2.1, which is currently the best open source video model out there. But they've made it even better, so they basically fine-tuned it, and here they say the training cost in USD is 200 times cheaper than training Wan 2.1. And then the dataset size is also 2,500 times smaller. Now here's where this chart doesn't really make much sense to me because they are fine-tuning it on Wan 2.1, which is the base model. So of course Wan 2.1 is going to require a lot more training and a larger dataset. So it's not really an apples to apples comparison because Pusa is more of like a fine-tune or a LoRa, which of course doesn't require as much training or data. But anyways, here is the impressive part about Pusa. So it's 5 times faster than just the regular Wan base model. Plus, it requires fewer inference steps. Now, like Wan 2.1, Pusa is also very flexible, so it can do image to video where you upload an image as the starting frame of the video. So here are some examples of Pusa in action. And below is the prompt, so you can see everything is very coherent and the quality is not bad. Here's another example with the prompt below, and again, as you can see, everything looks pretty good. Here's another example. And as you can see, it can handle text just fine. Here's a really cool example. So here is a microscopic view of a petri dish with cells undergoing mitosis and forming the shape of a smiley face. And that's indeed what we get. Or here's an even crazier example. So this is supposed to be an ice cream machine, but it begins to extrude a transparent frog. And that's kind of what you get. Now here are some higher action scenes. Here we can see a piggy bank surfing. And as you can see, everything looks very coherent. And it can also do different camera views. Here's a 360-degree video with a camel walking in the desert, and that's indeed what you get. Now, in addition to just uploading one image as the starting frame, you can also upload another image as the end frame, and the AI will kind of fill in the blanks. So here are some examples. Here is one example with the prompt below, and everything looks very accurate. Here's another example. This can also do video extension. In other words, it can take the first few frames of a video and naturally extend it to make the video longer. So here are some examples where we are given the first 13 frames of the video and it extends this to 81 frames. Or here's another example of a woman running through a library with flying papers. And of course, this can also do text to video. So here we're not uploading any image as the starting frame. So here we have a car changing from gold to white, and that's what we get. Or here's a dude sitting in a chair, then he gets up and starts stretching. And then here's a person eating a hot dog. This looks really realistic, by the way. Now, if you're interested in the technical details, Pusa uses a special technique called vectorized time step adaptation, which allows it to control the timing of events in the video in a more flexible way, and this makes the video look more realistic and coherent. Anyways, if you scroll up to the top of the page, they've released the dataset and the model and the code already. So the model is on Hugging Face, and if you click into their GitHub repo and you scroll down to the one section, this contains all the instructions on how to install this and run it locally on your computer. And it gives you various examples on how you can do all of the different features like image to video or start and end frames, and also video extension. Here it doesn't say the VRAM requirements for this, it only says that CUDA 12.4 is recommended, but it probably has the same hardware requirements as 1.2.1 since this is just the fine-tune. Anyways, all the links are up here, so if you're interested, I'll link to this main page in the description below. Next up, this AI is really useful. It's called Spatial Tracker V2, and this can take a video and track the camera motion as well as the movement of objects in 3D space over time. So for example, you can take this video and get the AI to track the camera movement of this scene, plus it can also track this person riding the motorcycle and map everything out in this 3D space. Or here's another high action example. Again, you can see it can track the camera movement specified by this box over here, plus the trajectory of the car as it drifts through this scene. And it can map everything in this 3D space. Or here's yet another example of some high action scenes like playing basketball or skiing, but as you can see, the AI is able to track everything pretty accurately. And then here are some other examples. Now on this page, which I'll link to in the description below, you can actually get to play with some of these results. So let's say here is a video of some dude passing this object around. Well, you can actually zoom out and view this in a 3D space. So you can see that here is the camera. This box basically denotes the position of the camera, and then you can move this scene around like this. And we can toggle this on or off. So if we toggle show trajectory off, you can see he's passing around a basketball. If we toggle this on, then you can see that it's tracking the basketball throughout the video. We can also adjust settings like the size of the dots in the point cloud, like this. Very cool. Or here's an example of a dude breakdancing. Here's the original video. Now let's zoom out so you can see the camera position and also view the scene in 3D, which would look something like this. Very cool. The nice thing is, if you scroll up to the top of the page, they've actually released a free Hugging Face space for you to try this out online. So here's what the Hugging Face space looks like. Let's upload a video like this and then press start tracking now. And here is what we get. Let me play you the original video first, which looks like this. And here is the reconstructed 3D scene. Notice that it's able to map everything pretty well in this 3D space, while also being able to detect the position of the camera. Let's try another example. So I'm gonna upload this video. Let me play this for you first. What a cute little robot dog, by the way. So that's the video, and then again, let's press start tracking now and see what that gives us. Notice that there's a estimated time to completion over here, and it says 19 seconds. So this is an incredibly fast and efficient tool. All right, and here's what we get. So we can play around with all of these settings, and if I zoom out, here is the reconstructed 3D scene. Very nice. Now, in addition to this Hugging Face space, they've also released a GitHub repo, and if you scroll down a bit, this contains all the instructions on how you can download and run this locally on your computer. So props to them for open sourcing and releasing everything already. All the links are up here, so if you're interested in reading further, I'll link to this main page in the description below. In robotics news, we have a new completely open source robotic arm, which you can print out for around $500 and build it yourself. So it's called HopeJR, and the robotic arm looks like this, with a complete hand with 5 fingers. This is quite an advanced and dexterous arm with 23 degrees of freedom, including 16 degrees of freedom for its hand, so it can do a lot of fine manipulation tasks that require some complex finger manipulation, such as picking up different objects. And like I said, as long as you have access to a 3D printer and some pretty cheap accessories, you can build this with as little as $500 in parts. The nice thing is they've open sourced everything, including some super comprehensive build guides and documentation. So if you browse further in the GitHub repo, this contains like all the instructions and templates on how to print this out. So that's the hardware side of things. And then for the software, it actually uses LaRobot, which is an open source library built for controlling, teaching, and teleoperating these robots. They also give you instructions on how to download and set up LaRobot and connect it to your HopeJR robotic arm. Now, the nice thing is LaRobot offers some really cool built-in features. For example, you can teleoperate this arm directly via an exoskeleton or sensor gloves. In other words, you can control how this robotic arm moves from a distance, and they give you all the instructions on how to do that in the same Hugging Face page. So, if you need a hand with something, pun intended, and you have a 3D printer lying around, well, you can actually print this out for pretty cheap and build this yourself. Props to the LaRobot team for open sourcing everything. If you're interested in reading further, I'll link to this main page in the description below. Next up, this project is wacky as hell. So it's called NeuralOS, and this is an operating system, but not really. So nothing is predefined. This is basically an AI model that was trained to simulate an operating system, and it can respond in real time. So on this page, which I'll link to in the description below, you can interact with this AI simulation of an operating system. So first, let me move my mouse over this area to interact with it. And you can see that here is a basic operating system. Now, when I hover my mouse over this, there's like a 1 or 2 second lag, but it is kind of generating the mouse cursor as if I was actually moving my mouse in an operating system. And then let's try to double click on Firefox. Let's see what happens. And it actually opens up a browser which looks like Firefox. So you can see different tabs at the top plus the Firefox homepage. Now note that this isn't pre-programmed. This isn't actually Firefox. The AI is just generating what it thinks the Firefox home screen would look like. Alright, next let me hover my mouse over this URL part and let me type google.com, and yes, it responds to my key presses as well. Really cool. Like I said, this isn't actually real. It's just detecting the keys I pressed and then kind of generating those letters in this URL bar. So next, let me press enter. And here you can see that it's kind of generating an imaginary Google page. Now, I have no idea what this is. Maybe this is like a sign-in window or something. All right, next I'm going to exit out of Firefox and try out some of the other apps on the desktop. Let me navigate to trash, and here is the trash of my imaginary operating system. And as you can see, it does look like, the trash or recycle bin. All right, let me exit out of this. And then next, let me click on this home folder and see what we get. All right, so it is pulling up my home, and let's see what we have for downloads. So if I double click on downloads, at the top in the URL bar, it does say downloads. And I guess it's just outputting 0 items, so it's empty. But there you go. That's just a really quick demonstration of what the heck this is. Like I said, this isn't actually any pre-programmed operating system. This is basically like a video that's generated by the AI in real time to simulate an operating system. And not only does this respond to my mouse movements and clicks, but it also responds to my key presses. So I can type in like google.com in the browser. Now, while this demonstration is very slow and clunky and very basic, this could be a glimpse into the future of operating systems where we no longer have anything pre-programmed. An operating system could just be a neural network which simulates and generates everything on the fly. In fact, the future of websites or apps could also just be neural networks. Anyways, that's just their demonstration, and if you click into this page, it basically gives you more information on what the heck this is. Now, the nice thing is they've actually released all the instructions on how you can actually create a dataset and train a similar operating system neural network yourself. So here are all the instructions on how to do this. Anyways, if you're interested in reading further or trying out this operating system, I'll link to this page in the description below. let me tell you about this awesome tool called ChatLLM by Abacus AI, the sponsor of this video. ChatLLM is an all-in-one platform for you to use the best AI models out there. You can seamlessly switch between different models, plus you can use the best image generators out there and the best video generators out there all in one integrated platform. Plus, if you're coding something, they have a really useful artifacts feature so that you can preview your generation side by side. Plus, they have a deep agent feature which can do really complex tasks all autonomously, like creating PowerPoints, websites, and research reports. It's gonna supercharge your productivity. You can access all these AI models and image and video generators and deep agent for only $10 a month. This is way cheaper than if you paid for each tool separately. Definitely check out ChatLLM that comes with deep agent in the description below. Next up, this AI is pretty mind-blowing. It's considered to be the next DeepSeek moment. So it's called Kimi K2, and this actually came out near the end of last week, so I didn't get a chance to cover it in my previous news video, but this is a state-of-the-art open source model developed by Chinese startup Moonshot. And Kimi K2 is especially good in frontier knowledge, math, and coding, making it as good or even better than some of the top closed source models out there like Claude 4 Opus. Now, this is a mixture of experts model with 32 billion activated parameters and a trillion total parameters, so it's fairly large, but it's hella good. And you can think of mixture of experts as like a team of AI agents working together to help you solve a task. Now, there's actually two variants to this. There's a base model, which is for research and custom fine-tuning, and then there's an instruct variant, which is good for general purpose chat or agentic tasks or autonomous execution. Also note that this is a non-thinking model. So unlike some of the top models out there like O3 or Grok 4 or DeepSeek R1, which kind of think through its answer before outputting a response, this is a non-thinking model, so it responds way faster. Now, if you compare this with the other non-thinking models out there, Kimi K2 is extremely good. As you can see, for agentic and competitive coding, for some of these benchmarks, it even beats Claude 4 Opus, as well as GPT 4.1, which is OpenAI's leading non-thinking model, as well as Gemini 2.5 Flash non-thinking. I'll show you some examples in a second to show you how incredibly powerful Kimi K2 is. And then for tool use, again, Kimi K2 is among the best of the best. Same with competitive math and graduate level questions. And in particular for tool use, basically it's really good at autonomously using tools at its disposal, like searching the web or using a Python coder or using a tool to create spreadsheets and PowerPoints, just to name a few examples. So here are some of their examples. I'm also going to show you some of mine in a second, but here, let's say you want to get it to create an interactive visualization website for this NLP lab, and you give it all this information, yada yada yada. Well, first of all, it searches the web to actually find what this lab is in real life and gather information about everyone and everything, including professors and faculty members. After gathering information, it's also visiting their individual pages to gather even more information about each person, and then also the students of each professor, as you can see over here. And then it's doing the same for the next professor, etc., etc. Next, it's designing the websites, and then it's also checking the website and fixing any issues by itself. Notice that this is all autonomous, just from one prompt. You don't need to prompt it further. And then afterwards, here is the result. Very nice. And you can see this genealogy graph over here. And there's even a nice timeline slider over here, so you can see like all the students from each researcher throughout time. Which one has graduated, which one is currently studying right now. How cool is that? And then here are some data analytics and PhD graduates by year, top destinations, research areas. I mean, this is pretty incredible. Or here's another example. You can easily get it to create a web version of Minecraft. So here it proceeds to create everything, and then here is the result. How insane is that? It created everything from just one prompt. And yes, this is interactive, so you can like jump and move around. Very cool. Now let's actually try this out ourselves. So this is completely free to use. It's just kimi.com, which I'll link to in the description below. And over here, make sure you select the newest one, K2. There are various things you can do, such as attach PDFs for it to analyze. You can also toggle this for it to search the web. And note that because K2 is a non-thinking model, you cannot turn on this extended thinking feature. But you can turn on this researcher feature, which is kind of like OpenAI or Gemini Deep Research, where it autonomously scours the web very thoroughly to find information it needs and give you a really comprehensive report. For me, I'm just going to leave it off, and then for my first prompt, let's try this. Interactive viewer of planet Earth, show dynamic lines of the magnetosphere, including the Van Allen belts. Import realistic textures, use Three.js, which is a library for 3D animations, and then put everything in a single HTML file. Let's press generate and see what that gives us. Alright, so you can see here it has searched for 28 web pages to actually verify how it would code this up. And then after synthesizing all this information, it proceeds to code everything up. And notice that this is extremely fast compared to the thinking models because, well, this doesn't have to think and reason. So let me exit this and then let's just click preview. And as you can see here, indeed, we have a visualization of planet Earth with a really nice realistic texture. And it does show these lines for the magnetosphere and these Van Allen belts. Very cool. It's actually quite realistic. So it does show two Van Allen radiation belts, the inner and outer one, and they gently pulse, as you can see here. Very cool. Now, the visualization is not perfect, but it's pretty good for just one prompt from a non-thinking model. Here's another example. I'm just going to paste this YouTube link and then I'm going to turn this into an interactive slide deck and then again put everything in a single HTML file. And here's what we get. Notice that it automatically searches the web and detected the title of this video. And then it proceeds to generate these slides. So let me click preview and here is what we get. Very nice. So here is slide 1, here is slide 2, and it does give you an interactive timeline. Here is slide 3, slide 4. Notice that this is also interactive, so this stock price does kind of fluctuate over time, and if you click this, it actually works. Let's click this again, and you can increase the shares owned below here. And then here's the next slide, and let's see what this does. Okay, very nice, and so on and so forth. So you can just plug any YouTube video into this and get it to create some interactive slides from that. Super useful tool. Or here's another example. Create an interactive Pokédex with the first 50 Pokemon, including their animation and stats. And here is the code. It's pretty short and concise. And if I click preview, here is what we get. Very nice. And yes, this includes the first 50 Pokemon. And over here, if I search Pikachu, this also works. And can I click on each one? Yes, I can. And look at that. It even gives me an animation plus all these stats. Very cool. Let's look at Butterfree. And again, everything works, plus it includes all these stats. I would say this is even better than what I got from Gemini 2.5 Pro. Or you can also get this to create educational materials or web pages. So for example, here I'm getting it to make an interactive educational page that teaches the following theorems. Include interactive visualizations for each one. And here is its answer. Let's click preview, and here is what we get. So here's the first theorem, and then here's the Pythagorean theorem. I can drag all of these to change the values, but notice that it maintains this formula. And then here is Heron's formula. Let's try to increase this and see what we get. Okay, and then let's set this to something like 12. Very interesting. So there you go. That's another example of how you can use Kimi K2. Now here's another leaderboard by Independent Evaluator Artificial Analysis, and as you can see here, Kimi K2 is indeed the most performant non-thinking model out there. So everything that's better than it are thinking models, which of course in theory should perform better. But Kimi K2 is the best non-thinking model, and it even beats, some of the closed source models out there like Claude 4 Opus and GPT 4.1. Now this is completely open source and you can download it and run it locally, but if you choose to use it via their API, then the cost is also extremely cheap, especially for its intelligence. As you can see here, it's only $1.3 per 1 million tokens. Anyways, if you scroll down over here, they've released a GitHub repo already, which gives you all the links on Hugging Face for you to download the model, as well as the code on how to deploy it and run it locally on your computer. So notice that the link is down here, and I will link to this main project page in the description below for you to read further if you're interested. Next up, this AI is incredibly useful. It's called Epona, and this can generate driving scenes and kind of predict what happens given just a few initial frames. You can also control the car's movements and specify its trajectories. So here's what it does. First, it would take in a few input frames to use as the start of the video, and then it would basically extend that video and guess what the future of that driving video would look like. And as you can see, if you compare this with other tools which I've gone over before, like Vista and Cosmos, they just perform way worse than this new method, which keeps everything way more consistent. And note that all these videos are sped up, but you can see the timer at the top right corner, so this can generate a minute-long video. And so, this is really good for predicting what the future of a driving video would be like given a few initial frames. And this could be very helpful data for training autonomous driving algorithms. You can even control how the car moves in the video using a trajectory like this. So on the right, we have two different scenarios in different settings, but here we are inputting the same driving trajectory. And as you can see, the AI is able to get the car to follow the trajectory that we specified. Notice that it also includes other settings like the speed and acceleration, and it's also able to kind of capture that in the video. So in a sense, you can think of this as just a video generator, but it was fine-tuned and trained on a ton of real driving videos. And so after training, if you prompt it to generate a driving video, it can do it really realistically. And then really quickly, here is the architecture behind it. So it uses this special multimodal spatial temporal transformer to basically process these initial frames of a video, and then it uses this next frame prediction diffusion transformer model, as well as this trajectory planning diffusion transformer to basically extend the video and kind of predict how the driving video would progress in the future. And again, all of these driving videos are really helpful for training autonomous driving algorithms. The nice thing is if you scroll up to the top of the page, if you click on this GitHub repo, this contains all the instructions on how to download this and use it locally on your computer. Anyways, if you're interested in reading further, I'll link to this main page in the description below. In humanoid robot news, Agility Robotics releases a new demo of their Digit robot. Here it's showing how Digit is able to autonomously maintain balance after experiencing a ton of obstacles. For example, getting a rug pulled from under it, which by the way is extremely hard for even a human to balance properly, as you can see here. Another test was having some weights dropped onto the container it was holding, but again, it's able to maintain balance just fine. Or here's another test where it's kind of jabbed with this stick thing, and again, it's able to maintain balance very well. An interesting thing to note about the design of Digit is that unlike other robots, this has a reverse knee design, kind of like an ostrich. Now, some really technical autonomy folks out there might say this isn't really the knee, but it's more like the ankle, which is true. But in robotics terms, they just call this a reverse knee. Anyways, Digit can carry up to 35 pounds or almost 16 kilos and is designed to adapt to different warehouse workflows and tasks. So it's great for doing repetitive tasks in logistics and warehouses. In fact, they've already partnered with Ford to help automate some of their warehousing and delivery operations. Plus, I believe they are also testing Digit at Amazon's robotics facility near Seattle. So definitely in the very near future, we are going to see a ton of these robots working in warehouses and logistics and manufacturing, and doing a ton of repetitive tasks that most humans do not want to do. In other robotics news, we also have this new dance video, this time not by Unitree or Engine AI, but by another Chinese robotics company called LimX Dynamics. And here we are seeing their full-size humanoid robot called CL-3 doing a very impressive dance routine. Now, this routine is obviously pre-programmed, but notice how quickly it can move its arms and legs. Like, this is super impressive. Now, a few stats about this CL-3 robot, because it's kind of under the radar and definitely less popular than the Unitree robots or Tesla Optimus. This CL-3 is approximately 5 feet 5 and weighs about 45 kilos. And it's actually super flexible, so it can perform lunges, squats, and even yoga-like stretches pretty naturally. And they actually use their own proprietary hollow actuator design, which provide high torque while staying light and compact. And this enables it to, move really quickly while being super powerful. Another really interesting thing about it is this robot actually learns from videos. So it just watches video clips of humans doing things like doing yoga or dancing or moving things, and then it's able to learn from that. So it doesn't actually learn from any sensors or motion capture suits. And this allows CL-3 to learn new skills really quickly without the need for any complex hardware. Here's another even crazier humanoid robot demo. This time it's from UBTech Robotics, and here it's featuring their Walker S2 robot. Here they claim that this is the first humanoid robot capable of autonomously swapping its own battery, as you can see in this demonstration, which is really cool. I wish my headphones or my phone could just autonomously charge itself. Anyways, obviously this capability allows this Walker 2 robot to work continuously 24/7 without any human intervention. So when it detects that its battery is running low, it can just walk to a charging station and remove a depleted battery from its body, dock it for recharge, and also install a freshly charged battery. And the entire process only takes around 3 minutes or less. And it doesn't need to power down or receive any human assistance. Now, the Walker S is designed to work in factories, logistics, and manufacturing, and is already deployed at various Chinese companies like BYD, which is like the Tesla of China. Now, I think in the near future, all humanoid robots are going to have this ability, where they no longer need any humans in the loop to, recharge. They can just do it themselves by walking to a charging station and swapping out their old batteries with a newly charged one. Next up, this AI is super useful. It's called PhysX, and this doesn't just generate any 3D object, but it can generate these objects with real-world physical properties, like the correct size and material and movement. So here's an example of a scene with a ton of its generations, and you can see the size of all these objects are physically accurate. And if you inspect any one of these objects, you can get the size of that object, as you can see over here. And you can also see that it segments this knife accordingly. And here affordance basically means its usage. So you can see one part is the handle and the other part is for cutting things. And for each object, it can also determine the material of that object. So for example, it would know that the top part is made of metal with this density. And you can also prompt it to find the part that provides a safe ergonomic grip, and that's indeed what it detects. It detects the grip of this knife. Or let's say instead, if you look at this chair, again, it's able to detect the real physical size of this chair and also segment the chair logically. And then afterwards, it's also able to detect the parts that are made of metal. And for example, you can prompt it to find the part that supports the user's right arm, and it is able to segment the right armrest. You can even put this chair through this wind test and see what happens. And again, everything is just physically correct. Or you can also try rolling balls of different masses against this chair to see what happens. And again, everything is just physically correct. If the ball is lightweight, then it doesn't have much impact, but if the ball is 50 kilos, then it's going to knock the chair over like this. Here's another example where we have this handbag, and this time it has detected that most of the material is made of leather. And again, if you prompt it to find the part that is used to carry the handbag by hand, it indeed identifies this correctly. And then here are some wind tests. If it's a light gust, then it doesn't do much, but if it's a really strong wind, then it blows the thing over. And then again, here is the standard ball test of different masses. So, this 3D model generator is way better than all the other ones I featured before because this one actually includes all the physical properties of an object, including the size, the materials, all the different parts. So this would be really useful for design or simulations. Anyways, if you scroll up to the top of the page, they have released a dataset on Hugging Face, and if you click on this GitHub repo and you scroll down a bit, it does say the code is coming soon. So hopefully they will release this. This is a really useful tool in terms of 3D generation. Anyways, if you're interested in reading further, I'll link to this main page in the description below. Also this week, OpenAI releases a new feature in ChatGPT called ChatGPT Agent. This is basically an agent that can autonomously help you do complex multi-step tasks online. So for example, it can help you book a flight given your criteria like this. Or it can also autonomously create a spreadsheet for you based on whatever you want. Or it can also create a slideshow for you like this. Now, if you've been following my channel, I've already featured a ton of these agentic tools before, and all of them can already do all of these things. So for example, we have Manus, which is kind of the first one that sparked this agentic race. But we also have GenSpark, which is really good. It can also just autonomously create slides for you or even generate images and create a pretty coherent storybook like this. It can also do pretty deep research and find a ton of information and synthesize it all into one comprehensive report. And then we also have Skywork Super Agents, which is incredibly good. So here's an example of using Skywork to autonomously create a PowerPoint presentation for you. And I mean, look how nice this looks. Anyways, going back to ChatGPT Agent, this is basically the same thing. You can autonomously get it to do stuff like booking flights or booking a table for dinner or creating slides, doing deep research and creating a report for you, and so on and so forth. What I really like about ChatGPT Agent is that you can also connect this to a ton of different apps that you use every day. For example, this integrates with Gmail and Google Docs and Microsoft 365, Notion, Slack, and other platforms to fetch and send data. For example, you can get it to send emails through your Gmail account, all within the ChatGPT interface. Anyways, here are some benchmark scores for your reference. So, for humanity's last exam, this is basically an evaluation of how much knowledge an AI model knows or is able to find, especially for really obscure scientific domains that most people don't know about. Well, ChatGPT Agent, which includes the ability to browse the web, that performs 41.6%, which is pretty damn good. However, they are leaving out all the other competitor AI models, and they're only comparing it to OpenAI's own models. So if you look at Grok 4, which was recently released, which I did a full video on, for humanity's last exam, if you also give it internet access, the heavy version scores 44.4, which is even better than this ChatGPT agent. So, they kind of released this a few days too late, where it's not as impressive. It's kind of outshined by Grok 4. Here's a key sentence that might be intimidating for some people. So here it says, on an internal benchmark designed to evaluate the performance on complex, economically viable knowledge work tasks, GPT Agent's output is comparable to or better than that of humans in roughly half the cases, while also outperforming O3 and O4 Mini. So basically here it says here for economically valuable knowledge work tasks, ChatGPT Agent's output is even better than humans in half the cases. And of course, it's a lot cheaper and you can use it 24/7. So what would this mean for, knowledge workers and related jobs? Here's a chart that's packed with a ton of insights. So here we have different types of tasks. Here is the time it takes a human to complete the task, some of which are like over 10 hours. But of course, these AI models, including ChatGPT Agent, just takes minutes to complete. And then here is the win rate versus humans. So we can just ignore the yellow and green bars, which is O4 and O3, and just look at the blue bar, which is ChatGPT Agent. And you can see that for all of these tasks, ChatGPT Agent, if you look at these confidence intervals, they overlap with the 50% mark. In other words, its output is as good or even better than humans in half these cases. Now, here's another interesting benchmark called Spreadsheet Bench, which kind of tests the AI model's ability in creating and editing spreadsheets. And here, it's not as good as a human yet, so ChatGPT Agent with this Excel access only gets 45.5, whereas a human gets 71.3. And here's another benchmark. This time it's on agentic browsing, so how well can it autonomously browse the web? And here you can see it significantly outperforms its predecessors, Deep Research and OpenAI o3. Now, unfortunately, as of right now, you do need to pay in order to use ChatGPT Agent. So here it says ChatGPT Agent rolls out today only to Pro Plus and Team users. Pro users, which is the $200 per month plan, will get access by end of day, whereas the cheaper plans will get access over the next few days. And then enterprise and education users will get access in the coming weeks. Plus, note that there is a maximum limit to this, so pro users only have 400 messages per month, whereas other tiers get 40 messages per month, which is pretty low to be honest. So anyways, that sums up ChatGPT Agent. If you are interested in trying this out or reading further, I'll link to this main page in the description below. Next up, this AI is also pretty useful. It's called Clift, and here's what it does. You would feed it a set of photos of a certain scene, and it would reconstruct a 3D scene or a video from that. It can create new views of a scene that aren't even in the original images. So for example, let's say you have these 6 photos of this room. These were taken at different angles and lighting conditions, but afterwards you can just plug it through this AI and it would stitch everything together, and it uses what are called these compressed light field tokens that basically reduce the amount of data needed to store these 3D images and videos while keeping the quality high. And after processing all this data, you basically get this 3D scene or video like this. And here are some other examples of some reconstructed 3D scenes. Now, here are some comparisons with other 3D scene generators. So this other one is called LVSMED, and this video is around 9 megabytes. Now, if you use this Clift one, it can output various different sizes, but notice that for the ones that are below 9 megabytes, the quality is just as good as this one. So it's really good at compression and creating an optimized 3D scene. Or here's a comparison with another one called DepthSplat. This is 14 megabytes in size, but you can see the details of almost everything in these scenes are pretty awful. Whereas for this one, even for the 11 megabyte version, the details are just a lot better and sharper. And then here are some more 3D reconstructions from Clift for your reference. Notice that for the most part, everything is very detailed and sharp, including the text. So really quickly, if you're curious about the technical details, Clift uses a 3-stage process. First, it tokenizes the image, or basically it converts it into data for the AI model to process. Then it clusters these tokens, and it removes any redundant tokens so that it can process this faster. And then finally, it compresses these tokens into what are called light field tokens, which are then used to generate new views of the scene. Now, if you scroll up to the top of the page, they have released a GitHub repo. Here they say the code will be released around August 1st. Anyways, if you're interested in reading further, I'll link to this main page in the description below. Next up, this AI is really useful. It's called Movies, and this can take a video and basically reconstruct a 3D scene from it, or what they call a 4D scene, because the fourth dimension is time. And from that video, it can detect a ton of different things. For example, on the left is the original video, and basically, if you feed it through this AI, it can capture everything in this 3D space, including the motion of the camera. So if you get it to reconstruct the scene, here's what it looks like, and notice that it's almost the same as the original video. Now, because it can detect everything in this 3D space, including the position of the camera, you can get the camera to stay still. So this is called fixed novel viewpoint, and if you do that, here is what you get. So notice that this can act as like a video stabilization tool. In addition to this, you can also predict the depth of the original video like this, or you can even predict the motion. In other words, what areas in this scene move over time. So the areas that are darker in color indicate higher movement. So as you can see, for example, his feet move a lot more than the rest of his body, and that's why his feet are darker colored. Or here are two other examples where on the left is the input video. Well, you can get this AI to reconstruct the scene, and it looks almost the same as the original video. Now again, both input videos are super shaky, so if you get the camera to be fixed at one position in time, here is what you get. And notice that it's really good at stabilizing the video. And then you can also get it to predict the depth of the video as well as predict the motion of the video. In other words, what parts move the most in the video. And there's even more you can do with this, so here are some additional examples. You can also get it to track certain parts of the video as they move. And you know, the spatial tracking is pretty good. As you can see from the scene at the top, even though it's moving very fast, it's able to track this car very well. Or as you can see from the bottom, even though the camera is super shaky and also moving really quickly, it's able to track everything in the scene with pretty high accuracy. And you can also use this to segment different objects in the video. So for example, let's say the input video is on the left. Well, you can get it to segment certain things in the video like this car or this mecha dragon creature at the bottom. Here are some other examples. And notice on the bottom row, even though this is a super busy scene, it's able to track the movements of your targets very well. Really quickly, here's how it works. So it would take each frame from your video and plug this through an image encoder, which would break the frame down into data and then feed it through this neural network to be processed. And then it goes through 3 different attention heads. One to detect the depth or geometry of the scene, another one to basically detect the appearance of the scene, and the third one detects the motion of the scene. And so afterwards, you can get it to basically predict all these 3 different things. Now, if you scroll up to the top of the page, they have released a GitHub repo, and right now they haven't released any code yet, but it is on their to-do list. Hopefully they will release this soon, because this is a super useful tool, especially if you need to segment, detect, or track things in videos. Anyways, if you're interested in reading further, I'll link to this main page in the description below. And that sums up all the highlights in AI this week. Let me know in the comments what you think of all of this. Which piece of news was your favorite, and which tool are you most looking forward to trying out? As always, I will be on the lookout for the top AI news and tools to share with you. So if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.